coming in and doing something for at least half credit. Sections blank can be deadly. Okay.
I just send it in.
Why are you just going off on me, man? Dude, what do you have in this class, man?
Today I want you to think about this for a second. Let's suppose that I took 5 of you out in the hallway. So I picked 5 of you, took you out in the hallway. How many ways could I line you up in a row?
5, 25. 5 times 5 times 125. Times 5
times 4 times
5 to the 5th.
No, not 5 to the 5th.
What did you say?
Those two said it.
Yeah,
Think about it for a minute. I want to line up 5 of you in a row. Okay, so here are my 5. I'm going to reach in and grab one and put you right here. How many choices do I have to put in this 5? 5, right? I have 5 choices. I'm not putting 5 people in that blank, but I have 5 choices. So I grab one of you and now you're there. Now how many are left?
4.
So I'm going to grab one of those and I have 4 choices for the next one. And then 3, and then 2, and then this guy is just left over. So all together, if I want to line 5 of you up in a row, I could do that. What is that, 120?
Yep.
Now,
I said 125.
I don't want to have to write this out every time I do one of these problems. There's a symbol I can use that will represent this very concept. 5 times 4 times 3 times 2 times 1. What is that symbol, Katie? It's an exclamation point. This is what we call 5 factorial.
Is this button on our calculator?
And there, that button is on your calculator. And 5 factorial, in a minute I'll tell you where it is if you haven't found it, but listen, 5 factorial means 5 times 4 times 3 times 2 times 1. So, if I took 12 of you out in the hallway, I could line you up 12 factorial ways, right? Which would take a long time to write out, and it's a great big number, so I like to type it in on my calculator. So if you go to your calculator, and you go to, and press the math button, Stu, you might want to know this. The math button, right under the alpha button, right there in the first column. It says a button that says math. Click over to PRB, probability. And there's your exclamation point. It is the 4th option down.
Wait, do you have to hit 12 first?
You have to hit 12. And then math, click over to prog, down, and it is a big number, isn't it? That's how many options there are. So, when we talk about how many ways we can arrange things in a row, it's real easy. If there are n things, they can be arranged n factorial in a row. So let's suppose that I'm going to go to the library and I want to arrange 16 books on a shelf. How many ways can I arrange 16 books on a shelf? 16 factorial. If you are arranging things in a row, it is so easy. If there are n of them, it's n factorial. Okay?
Ooh, I got it.
Now, a similar problem, if it says E13, that means scientific notation times 10 to the 13. Now, yes, factorials get really, really big. Now, let's think about this problem. It's a little bit different. Same basic concept, but a little bit different. How many license plates can be made with 2 letters followed by 4 digits. Alright, so let's think about this for a second. We're going to have 2, now wait, just think. We're going to have 2 letters followed by 4 digits, so a number. Now think about your choices here. You're going to make a license plate. You're allowed to have whatever kind of license plate you want. There are no rules. In a minute, I'm going to give you some restrictions. But right now, anything goes. All you have to have is a letter here and a letter here, and these are all numbers. How many choices do you have, Blakely? 26. You can pick any letter you want, and there are 26 letters in our alphabet. No. 26 again. I give you no restrictions. So it doesn't say you can't have MM. You can. Now I need a digit. 10, 10, 10, 10. There we go. Now, that is not a factorial problem. But it's set up kind of the way this one was, where you have choices. How many choices do you have as you arrange this license plate? Now, what if we, so you would multiply all those together. So whatever that is times together, that's the answer. Now, what if we said that there are no repeats? That this license plate you're making, you can't use the same letter twice and you can't use the same number twice. How would that change the setup of your license plate? It would still be 26 here, because there are 26, right? 25, 10, 9, 8, 7. That's exactly right. Because once you pick a letter from your alphabet, once you pick it, you can't choose it again. So now you only have 25 options to pick from. Okay? Let's try another one. Let's suppose I have 8 jumpers and 13 shirts. And I have to wear a jumper and a shirt. And you know me, who cares if it matches? Just pick a jumper, pick a shirt. How many outfits do I have? Well, I gotta pick a jumper. How many choices do I have? 8. And then I gotta pick a shirt. 13. And what am I gonna do with these two numbers? Multiply them together. So that's how many outfits I would have. It is exactly the same as picking a number and picking a letter. It's exactly the same thing.
Not worth it. We're not gonna find one anyway.
Alright? So let's try this. Let's suppose you go down to your favorite ice cream shop. Okay? And they, down at your favorite ice cream shop, they have, let's say, 10 flavors. Now, you can't decide if you want a 1 scoop, a 2 scoop, or a 3 scoop cone. You can't decide. But you know you're going to pick one. So you're going to get down there and you're going to decide. How many total, if you have to get either a 1 scoop, 2 scoop, or 3 scoop, that's it. They don't stack them any higher. Those are your options. How many cones are possible?
60.
How many kinds of cones are possible?
Can you repeat?
26.
Yep, you can have a double scoop chocolate or a triple scoop strawberry. No restrictions on repeating.
Oh.
All right, so now think about this for a second.
Oh wait, no, it's 30.
You're going to get a 1 scoop cone, or you're going to get a 2 scoop cone, or you're going to get a 3 scoop cone, right? All right, so how many 1 scoop cones would be possible? How many different 1 scoop cones would be possible? 10. You're going to get one of the flavors. You have 10 options, that's it. Now, what about 2 scoop cones?
Oh.
10 times 10. Now, if you had been told in the problem that you can't repeat flavors, then it would be 10 times 9. Now, one of the issues that we have is kids will say to me, well, how do I know? Boys and girls, you have to use your common sense. When you walk into Baskin Robbins, can you get 2 chocolate scoops? Yes, you can. So unless you are specifically told no, go with your common sense. The real world. How about 3 scoop cones?
10 times 10.
10 times 10 times 10. All right. So there are 10 1 scoop cones. There are 100 different 2 scoop cones. And there are 1,000 different 3 scoop cones. How many cones all together?
That's a huge.
1,110. Stop. Listen. You are either going to get a 1 scoop cone or you're going to get a 2 scoop cone. Right? You're not doing those together. You're not multiplying those together. You're going to have, there's this many possibilities, there's this many possibilities. How many all together? Add them. So here is another issue. Now, you guys are all wound up, and that's okay, but I'm telling you, this is a hard unit. Only because you really have to think. When we are doing things together and picking a jumper and a shirt, picking scoop 1 and scoop 2, you multiply them. But when you are considering these options or these options, you add them. So a 10 plus 100 plus 1,000 all added up are the total cones that would be possible for you to go in order. All right, let me try another one. Let's suppose you're going to go in and buy a sandwich. Okay? There are 3 kinds of bread, 4 kinds of meat, and 3 kinds of cheese. You are going to buy a sandwich. By definition, a sandwich has bread. Okay? So you are going to have either a meat sandwich or a cheese sandwich or a meat and cheese sandwich. Okay? So here we go. We're going in and we're going to buy a meat sandwich. So we got to choose, pretend you're at Subway, what kind of bread? Here we go. We got 3 choices.
4 times 3.
Sweet Italian with
And
ham.
4 meats. So how many meat sandwiches are possible? 12.
Okay.
All right, now we're going to buy a cheese sandwich.
9.
How many options? 9 cheese sandwiches. Now we're going to buy meat and cheese.
3 times
3 times 4 times 3. 36 of those? How many sandwiches are available for you to order?
57.
Add them up.
57. It is. Oh, wait. Yeah, 57.
Does everybody see the difference between when I am multiplying and when I am adding?
Yeah. 57.
Okay. Yeah, or means that. Yep. All right, we have one more thing that we want to talk about here. Actually, we have multiple things, but one more thing to talk about.
I've always wanted to go see it for the next source leader. I'll do whatever they want to do.
Listen.
She's Japanese.
No, I don't think so. How many ways could I arrange the letters of this word? I'm just going to cut them out and lay them down on the table. How many different ways could I arrange them?
9. 81.
I'm hearing some sixes.
9.
Where are the sixes coming from?
3 times 6.
Not 6.
Exactly. Kids, you cut out 3 letters. You're going to lay them out on the table. How many choices do you have for here? 3, and then 2, and then 1. So I could write them all out for you, and you could see what they look like. There you go. There are the 6 arrangements of those letters. Okay? Now, what about this word?
C. The same.
Now, it has exactly the same number of letters, right?
Oh, but it's 2 of the same letters.
So, if I were to distinguish the E's, you could see the various arrangements.
That's tricky. Tricky.
There are the 6 arrangements right there. Right? But in the real world, when you look at letters, they're not black and red, they're all black. So what would happen is, these 2 are really the same. And these 2 are the same, and these 2 are the same. So instead of having 6 options, I only have 3. Now, when we arrange duplicates, that's what we got here. They're called duplicates or repetitions. When you arrange things that include duplicates, you start out doing exactly what you did. You said these 3 letters could be arranged 3 factorial ways. That's what you start with.
Wyatt's birthday.
We're not going anywhere until I'm done with this point. 3 things, 3 letters, 3 beads, 3 jumpers, 3 anything can be arranged 3 factorial ways. If any of them repeat, you must divide by the number of duplicates factorial. So there are 2 E's, so I divide by 2 factorial. Now, I'm going to do the classic example. You know what it is. Mississippi. How many ways can the letters of the word Mississippi be arranged?
4 factorial.
No. How many letters are there? 11. So we start with 11 factorial.
66 ways.
And then you divide it by 3.
Now, how many I's are there?
4.
So you divide by 4 factorial. That's the I's. How many S's are there?
4.
So I divide by another 4 factorial. That's the S's. And then I divide by 2 factorial. That's the P's.
Do all those factorials in the
You
box.
always divide by duplicates factorial. These do not combine. When you divide them individually. Okay? All right, I need to give you a hug. I'll see some of you tomorrow. Alex.